In this video we're going to look how to find the inverse of a 2 by 2 matrix. There's two methods, and in the first slide here we're going to use the method of using determinants. Now the determinant value of this matrix, let's say this matrix is A, then the determinant value of A is equal to 1 times 4 subtract the other diagonal, which is minus 2 times 3, which is minus 6. So that is 4 plus 6, which is equal to 10. So that means that the inverse of this matrix will be 1 on the determinant of A multiplied by a modified A. And in the modified A we need to swap the numbers along this diagonal. So that means a 4 and a 1 will perform a swap. And we change the sign of the other two elements. So this becomes positive 2 and this becomes negative 3. So that means this is 1 over 10 outside of 4 to negative 3, 1, which we could write as 0.4, 0.2, negative 0.3, and 0.1. Now, this is exactly the same question, but this time we're going to do this by a process called row reduction. And we're going to start off with the matrix on one side of an augmented matrix, and on the other side we're going to have the identity matrix. And we're going to make changes to this matrix until we get the identity matrix on the left hand side, and the inverse will be found on the right hand side. So when you're trying to get this section here to be the identity matrix, you need a 1 in this cell position here. There is already a 1 in that position, so we don't need to do anything. What we need to do now is we need to perform row multiplication and addition. So what we're going to do is, this first row has just been made, we've just checked our 1, and we're going to multiply that row by negative 3, and we're going to add this row to row 2. The purpose of doing that is when you multiply the 1 by minus 3 and add it to row 2, that 3 will disappear. So the reason that's good is because it gives us a 0, like getting the identity matrix in this position. So we know that we have a 1 here, a minus 2, and then a 1 and a 0. And this top row is going to be times by negative 3 and added to that. So negative 3 times 1 is negative 3, added to 3 gives 0. Negative 3 times negative 2 is 6, added to 4 gives 10. Negative 3 times 1 is negative 3, added to 0 is negative 3. Negative 3 times 0 is 0, add 1 is 1. So now we've achieved the identity element for the first column. We've got a 1 and a 0. So now we have to start working on the second column, and we're going to go down and make this 10 into a 1 like we'd need for the identity matrix. So we're going to go through and we're going to divide that row by 10. Dividing a whole row by a number is one of the processes that you're allowed to do in this row reduction methodology. The other one is multiplying it by a constant and then adding it to another row. And another option that's available is the swapping of rows. So let's divide by 10. I'm just going to put just the 1 from the top row here, because we're going to have to do some modification in a minute. But dividing the bottom row by 10 will give us 0, 1, minus 0.3 and 0.1. And we know from the previous question that they're the numbers that we should have in those positions. I'll just write these in. I'm just doing more working than what I'd normally do. Now, to get this minus 2 to be 0, we're going to multiply this row that we've just got the 1 from. We're going to multiply that by 2 and then add to row 1. So in other words, row 2 will be exactly the same, but we're about to modify row 1. So if we multiply 0 by 2 and add it to row 1, we'll still have 1. 2 times 1 is 2, add to negative 2 gives 0. So now we have the identity matrix. 2 times negative 0.3 is 0.6, negative 0.6, add to 1 is negative 0.4, and 2 times 0.1 is 0.2, added to 0 is 0.2. And you'll see that this is now the identity matrix, this part is now our inverse. And you can see back at the previous example that was the case, except I couldn't rewrite numbers properly. So that's 1. I did nothing there. I just didn't rewrite this line properly over. Okay, going on to the next one. We're going to do the inverse by the determinant method. So the determinant value of this matrix is equal to minus 3 times minus 2, which is 6, minus 7 times 1 is 7, which is minus 1. So that means the inverse matrix is 1 on minus 1 outside of, swap the numbers on this diagonal, is minus 3, minus 2, and put minus signs in front of the other ones. This number out the front here, 1 divided by minus 1 is basically minus 1, multiplied by everything inside here just changes the sign. So we know the matrix is a very friendly 3, 7, 1, 2. Now, doing the same question, the other method, we'll set up our matrix augmented with the identity matrix. So this is our matrix, this is our identity matrix. Now, what we could do here is we could perform a swap. Wouldn't maybe simplify matters a little bit. So we're going to swap these two rows. So that will lead to us getting 1, negative 3, 0, 1, negative 2, 7, 1, 0. And now that we have a 1 in this key position here, we need to then use this row to get a 0 in this position, just like in the identity matrix. So we're going to times this row by 2, and we're going to add it to row 2. So I'm going to just rewrite that top row because that will remain unchanged. So 2 times 1 is 2, add minus 2 is 0. 2 times minus 3 is minus 6, add to 7 is 1. 2 times 0 is 0, add 1 is 1. 2 times 1 is 2, add 0 is 2. So now we have to work on this second row. We have a 1 in the right position, so we don't need to divide by anything to achieve that. But we can now take this row and we can multiply it by -3. Beg your pardon, multiply by +3. Okay, the opposite to what is here, and add it to row 1. So 3 times 0 is 0, add 1 is 1. 3 times 1 is 3, add -3 is 0. So that's our identity matrix. 3 times 1 is 3, add 0 is 3. 3 times 2 is 6, add 1 is 7. So now we've achieved the inverse matrix, and we can check back to the previous question and it's the same.